Hello, my name is Kun Duan from G Global Research, and this is a paper with my colleagues Wei Wang and Ting Yu. So the title of my paper is Procrustean Decomposition for Orthogonal Cascade Detection. Our goal is to speed up a sliding window detector while maintaining detection accuracies. So in previous work, most of the speed-up techniques for object detection majorly involves feature engineering or reducing search space. For example, building a cascade from scratch or performing branch and bound search. Our approach does not involve any feature engineering and take a similar approach as the second one. Firstly, we run given a Procrustean object detector, we run an orthogonal decomposition with the iterative and simple fast algorithm and decompose the original detector into multiple orthogonal and components without any redundancy. And then we perform rank 1 approximation on one of the component detectors and decompose this single component detector into a column filter and row filter. And finally, we build a cascade detector to speed up the original detection. So in more detail, the first step involves something called orthogonal decomposition. Given the original detector, our goal is to find a set of component detectors, W1 to WP, which can reconstruct the original detector while they are orthogonal to each other, which is guaranteed by the constraint here. And this formulation can be reformulated into a form of generalized orthogonal Procrustean problem and can be solved using a simple iterative approach. One interesting property of our method is that the solutions on the previous slide has an interesting property. That is, the sum of the component detectors is equal to the original detector. This allows us to use a simple learning-based method to learn the cascade rejection thresholds if we put the component detector in the cascade. In more detail, and then we perform a rank 1 approximation on one of the component detectors and use that as the first cascade layer. This decomposition is done using SVD. We use two datasets for our experiments. One dataset is India person, and another is Pascal VOC 2007. And we use two different kind of features, which is HOG and CNN. And one take-home message is we found there is a trade-off between the complexity of our cascade between against the speed-up factor. A lower P tends to give a better speed-up effect, while a higher P tends to give a better peak performance. And this is some similar sample results on Pascal datasets. We also did another set of experiments showing that our method is better than other baseline decomposition methods. As a conclusion, our method is a generic orthogonal decomposition framework, and there's no constraint in our method on the choice of image features, and we obtain significant speed up for sliding window detectors.